I need to look like I'm doing something. And I thought it'd be interesting, just rather than everybody knows what spreadsheets are used for. It's just a list of numbers. You might put a graph in there and then drop it into your DTP or your word processor or anything like that. And that's really what most people will use a spreadsheet for. But I just thought I would show you one that I've worked on in the last couple of years, but also a bit of interest about what the application is, and just some general information that Peter can use at his quiz next month, so pay attention. So for my sins, one of the things I got involved with was warning lights. This is an industrial warning light, just flashes, a small strobe tube and obviously a circuit under there to do it. But the majority of what we used to do were automotive warning lights. Now, you can't just stick anything on a vehicle. Might shock you, although VW probably think you can. But you can't. There's strict regulations about what you can put on a car and what you can't. And basically it comes down to the fact that now cars have become more electronicized, for want of a better word, automated certainly, but automated with very fast computers, electronics. There's data whizzing around the car down twisted pairs on the CAN bus at very, very fast speeds. And it's become more important that anything connected to it doesn't interfere with that. You don't want the brakes to come on when you turn your radio on and so on like that. But ironically, radios are exempt from a lot of these regulations. But so a lot of this is now governed heavily by regulation. Even more so if what you're deemed to be either putting on the vehicle is what's called a safety-related product. And clearly, a flashing warning light is a safety-related product, because if it fails to function or malfunctions, i.e. goes off at the wrong point, people can get the wrong impression that there's a hazard when there isn't. So these things have to be designed in such a way that they meet certain regulations and then tested. And for this sort of product, there's two main tests that you have to pass. There's one called UNECR10, which is EMC. So I take it most people know what EMC is. If you pass an electric current through a wire, it generates a magnetic field. That's EMC. The problem is, when that magnetic field crosses other wires, it induces voltage in those cables, and that's where the interference comes from. So if you generate lots of EMC, you can interfere with other systems. The regulation has a UN in front of it, because these aren't EU regulations. It's not Europe or anybody telling us this. It's United Nations. So all these now, there's 57 countries signed up to this United Nations group of regulations. And the EMC one is R10. They start at R1 and they go up to about R120 at the moment. So there's a whole raft of these, and these cover EMC, fog lights, headlights, reversing lights. If you go and look at all the lenses on your lights in your car, you will see probably a big circle with a big E in it, a little number next to it, and then a certificate number next to it. And there might be lots of those on. If you've got a multiple light cluster at the back, there'll be one for the indicator, one for the brake light, one for the tail light. They're all covered by different regulation numbers. So R10 is EMC, which is quite an easy one because you don't have to test for it once you've designed the gear. The other one that we got involved with for lighting was what's called R65, and that is a test that you have to do that covers lots of various things. So I touched on some of this once on my programming talk, but that's the sort of thing we're looking at for what you would take as a classic beacon. And that's an LED beacon, and obviously most of the time LED beacons tend to flash. This was one that I programmed to do this simulated rotate, but whether it's rotating or flashing, it doesn't matter. It has to comply with the regulations. And the regulations state that we've got to be able to make sure that, first off, the flash is a certain frequency, that the amount of light is within certain limits, that it's going in certain places, and the last one is the colour of the light. So those four things have to be measured. So we'll just talk a little bit about light and what is light, because that's the crux of how we're going to measure it and how we're going to set the spreadsheet up to decide whether this thing passes or not. So we all know sort of what light is because obviously we see it, but most of the light we see is reflected light. All the light that you're seeing here, other than what's coming from actual light sources such as the bulbs, is reflected light. Anybody want to hazard a guess of which colour light the eye sees best?
Green.
Correct, green. I was hoping somebody would say amber or blue or red because that's what you the emergency light you see. But no, it's green. And we have here the colour that the eye sees. And obviously this is the wavelength across the bottom, so we're going ultraviolet down here through the visible colours of blue up to green, and then we see amber and red. Now, so you might say, well, why don't the emergency services use use green and not blue, which is right at one end, and not red, which is right at the other? And the pure answer is that you'd hardly see it. There's so much green about, and you're so used to seeing it that you wouldn't really notice. So what they're trying to come up with these emergency lights is a contrast to what you're normally seeing. So that's why.
Does a doctor on call have a green light?
A doctor does, yes. Yeah, a doctor does.
Thought to see one.
Yeah, simply because when they decided that was sort of the last one that was added to the list, and it's like, well, what else can we use? Nobody's allowed to have red and blue except the emergency services. Amber, it was just seen as well. Breakdown trucks have amber, so they thought, well, what's left that we could usefully use, and that's green. So that's how we perceive light. So we measure light in different ways, depending on what we want to measure. But basically, to measure light, we've got to collect it somehow. So generally, you can, I'm sorry the picture's a bit small, but light can be measured in certain ways, and one of the ways that it's done is something like this, and I don't know whether you can see this, but this is two halves of a giant dome. And it's brilliant white inside. And you can put whatever you're measuring in there, close the dome up, power it up, and then within the dome somewhere is a very small hole that has a sensor in it. And what happens is that because it's a perfect sphere, all the light bounces around, and at some point it will hit the sensor. That's how it works. So the sensor can collect every little bit of light that's being generated within that dome. Which is great if you want to measure things like how much light the light fitting's giving out and that sort of thing. This is what you would use. The problem here is these things are incredibly expensive. A dome, if you think, these fittings would go in something like that, but if you've got a 3-metre fluorescent fitting, it's not so easy to get it in there. And, they can cost tens, hundreds of thousands of pounds because it has to be a perfect sphere, it has to be perfectly white, so there's a lot of engineering goes into providing that, and then obviously there's computer and measurement devices here to measure the amount of light. And this is called a goniometer, and that's what it does. It just collects all the light and tells you how much it is. Use a lot of luminaires. When you see a luminaire, you'll see often the light is quoted in lumens. That's one of the sort of accepted measurements of light. You might see lux said somewhere, and lux is simply lumens per square metre. So if I've got a light that gives off 10 lumens, if I move 10 metres away, the light there is 1 lux, because I've got so that's how that works. Lux is used mainly in light, and you'll see the engineers go around with a light meter that tells them the lux, and it will depend on how high the ceiling is, how far away the luminaire is, but they have to have a certain amount of light, usually 1 metre above the floor, so that when the room's full of smoke and you're doing this to find your way out, that's the minimum amount of light. And for emergency lighting, which is another industry I used to be in, it is incredibly low. You wouldn't believe, you might as well get a candle. It's in fact, they used to be called candle power, but it is incredibly low. So that's how light is generally captured. But for this, we don't want to know how much light is coming out of the total thing. It might be interesting to know, but that's not what this particular regulation tells us or asks us to do. So what we're asked to do, we're asked to solve this equation in the regulations. And this gives us an amount of light, and it's what's called, it's measured in candela. This is the other measurement of light. There's lumens, and candela. And again, candela is the almost the opposite of lux. That's lumens per, depending on how far away in terms of meters or feet squared. But it's not affected by distance because you measure it at the distance. Where if you measure lumens with this, you can calculate the lux just by the distance. You have to measure candela at the right distance because that's just the way it works. So we've got an equation here. Looks horrendously complicated, but you break it down, it's not too difficult. The key to this is this, JE, which is, they're calling it effective intensity. And this is quite an interesting thing here. They're asking you to measure the peak intensity, so what's the maximum amount of light that's coming out from the thing. And there's a constant involved there, which we'll discuss. And then this equation of F times T. Well, T is the time, no problem, we can measure the time on a scope. And F is the amount of light times the time, divided by the peak times the time. So we're measuring the amount of light that's coming out and we're doing various things with it. But the point is, why isn't it just a measurement of the actual amount of light that's coming out? And what this equation says is that, and this was investigated a lot in the early 1920s, and this equation comes from about 1924. It's called the Blondel-Ray equation. But what it's basically saying is, your eye picks up a flashing light a lot more effectively than it picks up just a steady light. Your brain is programmed to notice changes. Once something stops changing, your brain is programmed to switch off and say, right, I've seen that, I understand that. You want to see a lion in the jungle running at you, you're not bothered about one that's sat and not doing anything. So that's where this comes from. So what they worked out, they did some tests, and they worked out that a flashing light, or a moving object, if you like, however you want to describe it, your brain is 5 times more likely to pick that up than a steady one. And that's what this 0.2 is here. 1 over 0.2 is 5. So that's effectively multiplying this by 5 to say you don't need as much light because the fact that it's flashing gives you the warning. So that's what we're trying to solve. Right. So how do we go about it? Well, first off, we've got to measure the light. We don't do it with a goniometer. We do it with one of these things, which is basically it's a current meter. It reads very low levels of current. So what we have is a dark room somewhere. We have whatever's flashing at the end of the room, and we have a method of measuring it, and this will be something like a photo, where it is a photodiode. So in other words, it's a diode that's reactive to the amount of light that's coming into it, and it produces a current dependent on the light. And that's what we measure with this. This is a current meter, and I'll pop you up the spec sheet for it from the manufacturers. And you can see what it's measuring down here. Accuracy, its full range is 2 milliamps. So that's its full scale. If you read more than 2 milliamps, you need to either move it back a little bit or turn it down or something like this. And its minimum range is 0.2 picoamps, which is a heck of a low amount of current. But it will do, it's highly accurate. And obviously, like I say, the closer you are to the light object, the more current you will read, and the further away, the less you will read. So that's what we're going to do. We're going to measure the amount of current coming out of that, and then we're going to try and implement that equation, which I'm sure you all remembered, to say, does it pass or does it not pass? So, how are we going to do it? There you are. Told you it was easy. So, what we've got to do is we've got to effectively... Oh, no. Oh, that's okay. It's not video. Fine. So, we're going to measure something and put the results into here. If only it was so simple. Because as we found out, there's a lot of ifs, buts, and do mind if I don't on something like this. So I said it's got to be within a certain frequency. So what is that? Well, it's 2 to 4 hertz. So you've got to put error checking in to make sure it's not less than and it's not more than. The light's got to come out at certain places. Now, there's nothing the spreadsheet can do about that, other than give you the facility to enter it at various angles and so on. And the way this works, I'm going to get the trusted painting program up. I'll try and show you. What the hell is paint? Right, the way it works is, imagine we've got a beacon. Like that. What these regulations say is this is a uniform product around 360 degrees. So, in theory, anywhere what they would do is they would measure all the way around it, and they would use the lowest figure as the figure by which you've got to pass the regulation by. And then what they will do is they will tilt it 8 degrees that way and measure all the way around again. And then they will tilt it 8 degrees that way and measure all the way around again. Now, if you measured every degree, that's 360 measurements times 3. So it's a lot of stuff. With something like this, you can say there's not that much difference from there to there to there to there, because it's a uniform lens pretty much. There's little ribs in it, but they're not optical effect ribs, they're just to make it look nice. So you could, with this, you could get away with doing one measurement and tilting it until you could do 3, and you could reasonably argue that it's going to be the same all the way around, because the light source is uniform, the lens is uniform, colour should be uniform. So that's what we would do on a beacon. Some beacons aren't quite so uniform. Some deliberately have, well, the one I showed the video for deliberately has more granulations in the lens because of what it does. So this one, I don't know if you can just see that it has ribs like this, but these are proper optical ribs. They do affect the light. So with something like this, you might say, well, let's do every 15 degrees or something like that, just to make sure, and so on. So the spreadsheet needs to be able to give you an option of entering the data that's coming straight out there, entering the data that's coming up there, and entering the data that's coming down there at a reasonable number of angles. So what we do with this is we allow certain angles down here, and you can see that this is at this is minus, it's saying minus 0 because we've not introduced the data at the top, but this would be minus 8, 0 and plus 8. So already we've got quite a bit of stuff. This was 0 to 180 and 15 degrees. So this is the left half and this is the right half going the other way. And the reason this is split up is, again, when you've seen the tops of police cars with the bar, that's obviously not one of these. But believe it or not, it's tested exactly the same way. There's no difference as far as the regulations are concerned. So what they do with that is they say, well, if you've got, looking down on it now, if you've got a light bar, if it's a modern LED light bar, it would have light sources as LEDs on little circuit boards in the corners. That's typically what you see. If it's an old-fashioned light bar, it would have effectively a beacon in each end, like that. Some of them then will have a mechanical baffle to block the light out, and they'll have some writing here like police and a couple of bulbs to illuminate it. So how do we test that to be the same as that? And what the regulations say is, this is 180 and this is 180. So that's what you're testing. You ignore the bump in the middle, effectively chop that out, put the two ends together, and you've got, again, a 360 degree light source. So that's what we do. Again, tilted, plus and minus, and so on. So that's how we're going to do it. Did I also say that amber and blue are different? They are. Amber and blue, first off, if it's amber, you tilt it 8 degrees. If it's blue, you tilt it 4. Also, amber has a certain pass level, and blue is about half that. And nobody has yet successfully told me why. We don't know whether the eye sees blue different to amber, which I don't think it does. It's just that for some reason, the regulations for blue, which is clearly police and emergency services, it's a much tighter and lower light level threshold. It could be that blue light is harder to generate than amber. Amber is very close to yellow, which these regulations, don't forget, started years ago with incandescent bulbs. Amber is sort of the natural colour of that sort of bulb light, or it's erring that way anyway. Blue is very difficult to do. You need either a very white light through a very deep blue lens, which naturally blocks out a lot of the light, or with LED. Blue LEDs aren't as powerful as white LEDs and amber LEDs. So maybe that's got something to do with it, but nobody can give a proper explanation. So we're going to put data in there. Did I mention there were 2 levels of light as well? There's a night and a day. Oh no, we'll come on to that in a bit. So there's what's called class 1, which is nighttime, which isn't as bright because you don't want to be blinded. And there's daytime, class 2, which is 2.3 times brighter. So we've got to deal with angles, flashing frequency, class 1 and class 2.
I'm interested, Dave, you mentioned the nighttime setting, because I often wondered if there was one, because sometimes you come upon the scene of an accident, particularly in an area that's not street lit, and if there's several emergency vehicles, you just cannot make out where you are. There could be a copper standing there with a high vis and you wouldn't see it.
No, it's just too bright.
But all that will be the nighttime level. Believe me, the daytime level is very rarely done because it costs you more. It costs you more to generate 2.3 times the amount of light. And the regulations say if you're only going to provide one level, you can get away with the nighttime level, even though you might be driving around in the day using it. We did produce a bar, I think, and this is on the nighttime, the daytime level in the day. Look how bright that is. And we were asked to turn it down because it was just it was just horrendously bright. It was black. You can see the cameras trying to deal with this by sort of making the rest of it quite dark, but it's still pretty bright. And don't forget also that with LED, passing something like this regulation with an ordinary bulb is easy. Bulbs give off loads of light. There's almost too much light. LEDs are different. You're paying for every little millilumen that comes out of that LED. And therefore you've got to get it going where you want it, and that's the job of the optic, and that's why LED lights have a lot more complex optics, to put the light where you want it, because the light costs money. The upshot or the downside of that is you can be going along, not seeing it, and all of a sudden you hit the level at which the optic makes the light work, and it's like, wow, bloody hell, nearly blinded myself, because you've just come within its optical angle. So we've got various different angles, we've got various different colours that need different pass and fail levels. So it's starting to look quite a complex setup. And did we mention there were different colour limits as well? Oh no. Right, we'll get on to colour. So colour. We spoke a little bit about colour and the colour that the eye sees most. And obviously we're going to be working blue and red and amber somewhere here. Some people think amber is yellow and red. It's not. It's orange and red. So orange is yellow and red. So it's like yellow, orange, orange. It's like going north, northeast. It's more on the red side than it is on the yellow side. It's amber. So we've got frequency to think about. We've got all that, but we've got colour. So how do we measure colour? Colour measurement is incredibly difficult. The equipment to measure colour, called a colorimeter, is quite expensive usually. These things can range up to and past £50,000. And you think, why are these things so expensive? And the reason being that photometry, the measurement of light and colour, is used in a whole host of different ways that you just really wouldn't believe. The ILT that I showed you there, its main area of use is not measuring flashing lights or anything like that. That's a minute portion of it. What these things tend to be used for are a lot of biology and things like that, looking at cancers and looking at that, because these sort of things give off minute variations in the colour wavelength depending on whether you've got a certain disease or whether food is ripe enough. So there's all sorts of different applications of colour, and that's where a lot of this is driven by. It's not so much the measurement of flashing lights. Colorimeter, we've got to put that in somewhere, and the graph that we showed, this equation, is skewed slightly. So we're going to go with this. Now it looks the same, but it roughly is the same. But you can see it's been turned sideways, and now we've got the scale of wavelength around the outside here. So this is this thing. So blue starts about 450, as you can see here, and goes round to deep red at about 700. So it looks the same graph, but it's been tilted. And this one has just got some helpful stuff on, which we'll get rid of later. But this shows this line here is effectively the white line. So when somebody says, oh, it's a 4,000 colour K bulb, that's what it's going to look like there. When it's a 5,000, it's about there. When it's 6,000, you see you're going from what's called warm whites, which is your ambers, your yellows, down to cold white, which is your blues. So that's the white line. Obviously, perfect white is sort of where these three converge at around 5,760, which is usually what your monitors are calibrated on. So we've got this graph here, and you can see what's been done around the outside is we've now got an X and a Y axis, and it's been split up into squares. So what we do is, what the colorimeter does is it gives us an XY value. And what we do is we go do, bang, that's the colour. So what the colorimeter does is it changes the colour it's reading and gives you effectively its position on the XY axis on this graph. And again, this is a very old graph from about 1931 of a colour organisation that came up with this to say this is how we should be measuring colour. What colour's not on there?
Black.
Yeah, why?
Black's not a colour.
Black's not a colour. It's absence of colour, exactly. So it's the most common thing I ever get asked is that, where's black? And it's like, black's not a colour.
It's on the lines.
Yes. So this is all the visible colours. So if you measure colour and you plot it on the graph and it comes out somewhere down here, you've done something wrong, or you've found a new colour that nobody else has ever seen. So this is all the visible colour that we can get. Okay. And that's, that's the diagram, as I say, without the wavelength. So it's simply, we're going to get an X and a Y, and we're going to go bang. That's where we need to be. We've then got the difficulty of saying, is that a pass or is it a fail? And there's limits for those, but the limits aren't given very nicely in terms of 0.3 and 0.5 up. It's not that simple, but we'll have a go. So, like I say, back to the old spreadsheet. So, yes, we could have just provided the user a quick thing to deal with that equation and say, put all these in, and it will spit out a figure. But what you're doing with something like that in this sort of industry is, these sort of tests are very complex tests, and they're not done all the time. So what you get is the technician saying, well, I've forgotten how to do that, or I've forgotten what the regulation says in terms of what the maximum is or the minimum is. So all that has to really be built into this. It's almost like writing a piece of software. You've got to give them a whole system that they can't really do anything wrong, and it can't tell them it's passed unless it has passed. So that's the difficulty. So how do we go about it? Starting at the top, what I did is, first off, we've got to give them the option to tell the software, to tell the spreadsheet what it is that's being tested. And there are several options. We've seen beacon. Did I mention there were directional lights as well? Oh no. A directional light, at the front of a refuse truck where you see the flashing things on the front, well, they're clearly not one of these. They clearly can't measure them all the way around, because you get to the back of it and the refuse truck is bolted onto it. So that's something else. That's called a directional lamp, because it goes in a certain direction. And you're not be surprised to know the angles are all different. So we need to be able to deal with directional lamps. And there's other things like hearth bars now. The regulation is just being flooded with, as people invent new light sources, the regulations have to deal with it. But at the moment, we've got beacon, light bar, half bar and directional. And in reality, there's still only two types. There's a 360-degree light source, which is the top three of those, and there's a directional light source, which is something you put on a flat surface and it shines out, and that's the bottom one, directional. So we'll look at beacon for now. Now, something should have popped up. I think I've got this one. No, we've only got a half bar. We'll choose half bar then on this one, because I've only got a beacon set up. So I'll put that in, and you can see straight away what's happened here is it's starting to list some some stuff. And what I wanted to do is, what happens with this stuff, as I said at the beginning, you can't just put anything on a vehicle. It has to go away for testing. And it has to be tested by an independent test house. You can't do the test and send the results off. That's not allowed. The sample has to go away, you can't mess with it, it gets tested, it passes or it fails, a report goes to a government agency, and the government agency will give you a certificate with a number on it, with their stamp on it, with a copy of all the drawings that you sent off, all stamped, and that's what you get, that's your certified product. And you can't change it after that, you can't even call it something different, you can't change the name, you can't change the model number, you can't change the brand on the side without you tell the government agency. Because what they need to be able to do is when they're digging this out of a crashed vehicle that didn't work, they want to be able to go, that number, go to our records and we find who it is. So that's why it's taking that seriously. So, rather than enter all that information every time, what I wanted to do was provide them a database of, once you get a certificate that's been stamped, put the details in there, and then when you come to do the test on it, because you have to test these periodically when you manufacture in your own factory, it will pull up the details automatically for you. So that's what this does. So we have a simple table of where they can enter all their product certifications, and they can say what it is, and so on. We're going to talk a little bit about the Acorn versions of spreadsheets right at the end for a few minutes, but this was the fundamental thing that it fell down on first time. What you want to be able to do with all these things, you will all know from websites and everything else that you ask for your email and you ask for the confirmation, you type it wrong, you spell it wrong, you spell your name wrong, whatever. Data validation is a big thing on these things. Computers will do what you tell them. They're not very intelligent. So less than, greater than, equal to, all depends on the quality of the data that you put in. The old adage, garbage in, garbage out, is very, very true. So what you want to do with something like this is limit the user input from a list that they can't change. They can't type into there. All they can do is choose from a list. None of the Acorn spreadsheets can do that. And that is about the first thing that you want on something like this. It's the basics. It's to be able to just validate the user input. Anyway, we'll come back and we'll look at that then. Again, things like these where they can type, it doesn't matter. It's not important to the spreadsheet what the certificate number is, what the model is, what the brand is. It's not important. Once you get onto other things that are, how many light sources are in there? Primary light sources, that's got one primary light source. If I put one of them in each end of a light bar, it's still one primary light source. If I put two in each end, it's two primary light sources. So there's various things that it needs to know about that. Colour, fairly simple, amber, blue, red or white. Lens colour. Now it's doing this simply because you can get multiple certifications for things and it wants to make sure it's got the right thing. So it's asking for various things. The class 1 or class 2, day and night, if you remember. Voltage, light source type, and that's important for the spreadsheet and we'll go into why. And just some reference values, what was the value it passed with? And then the beam type, did I mention there was a wide beam and a narrow beam? There is. So there's wide left, wide right, wide both, or narrow. So all of that goes in there. And then when we go to here, all I have to do then, once I've told it it's a beacon, it's listing all the certificates for me that apply to, half bar in this case. And I can go here and I can choose that one, and I can choose the model. And the reason it's not just pick model off there is because on the same certificate you can list as many models as you want. So there might be several different models on there, all have the same physical attributes, but some different customers might want the different model numbers and they don't know who the original manufacturer is. So again, it's just a way of doing it. And you see what it's done there, it's filled in the rest of the things. And what it does there, it does what's called a VLOOKUP. You can see it here, VLOOKUP, from the certificate number, what is the rest of the data? That is another thing that the Acorn spreadsheets get wrong. They do it, but they don't do it the right way. They assume, or they force you to have the list in ascending order. So, and it's like, well, it might not be in ascending order. You know, we don't want the user to have to, you know, if they get a certificate 3 years down the line to think, oh, it goes up there, we need to go in and mess with that lot. So again, it's a way that Excel will let you do things a lot more flexibly than at the moment the Acorn stuff will. But anyway, so we fill in all the data from the certificate, and that's that bit done. The user's put in what he's going to test. and then we've got equipment setup. Now, all this in red was really calibration data. The user, once this is set up, they shouldn't need to change this, but it just gives them the chance to do it. So we've got things like, how far away from the light source are we? Calibration factor, how long we're going to measure things for, 60 seconds in this case, and so on, so on, and so on, and so on. So what type of test we're doing, it's information only, and we'll explain what that is later on. So that's it, that's that bit done. And again, that shouldn't change. And then this was one of the fun bits to do, because what you've got to then do is start actually measuring things. And one of the things that it needs to know is how many times does it flash. And the reason is, the unit we've got here, if you remember going back to the equation, one of the things we want is this peak intensity. Well, shock horror, this doesn't tell you what the peak intensity is. It can't. So it's like, oh, how are we going to do that? And there's peak intensity 2 places in this equation, one there and one there, one in F and one in there. So how are we going to do it? What this can tell you is the average and what's called the integrated value. So anybody remember their maths from school?
I deliberately try not to.
Oh, you must do. So, just get rid of this. Right, maths from school then. So, we're going to get, effectively what that meter sees, if I was to show it on an oscilloscope, is a series of pulses like that. Let's say it's a 3 pulse. Well, excuse my drawing. Then there'll be a gap, and there'll be another 3 later on. From there to there is the frequency in time. That's fine. We can measure that. How do we know what this peak is if the instrument can't tell us? This is the cunning bit. So it's effectively going to tell us. What the integrated value is, and what that is how much total light has this thing seen. So in other words, it's going to say, I'm adding up all of that, and I'm adding up all of that, and I'm adding up all of that. And then when I get to this one, I'm going to add that to it as well. I'm going to add that and add that. However long you leave it running, the amount of light that it's seen increases and increases and increases, and the number it's going to tell you just gets bigger and bigger and bigger and bigger. So what we decided to do was to say we'll measure for 60 seconds. So effectively what we will end up with, just wipe all this again. Effectively what we will end up with is a chunk of light, effectively all these spaces removed from it. And the machine will effectively say, I've measured that much light. But it still doesn't tell us what that is. So, how are we going to do it? Sorry? Exactly. This is a rectangle. So we know how long it was. We measured for a minute. We know how many times it flashed within that minute because we've measured it. We know the width of each pulse that makes up that because we measured that. So therefore, we know it's told us the area effectively. That's the integrated figure. So if we divide by that total time, we get the height. Spot on. I think anybody would get that. So we get a chunk of light. What's the problem with that?
It's not the intensity, that's just kind of like an averagey kind of...
It will tell you we'll get back to that. We can work out the intensity from it. The problem is, it only works if these are nice rectangular pulses. That's the only way it works. Now, fortunately, that's exactly what LEDs are. LEDs turn on and turn off so fast, you can effectively consider these to be vertical. Now, this is a strobe tube. A strobe tube would look something like this. As the strobe tube strikes and then it decays slightly. So that's not, you couldn't do that this method. A rotating one would probably look something like that. As the mirror comes round and then there's a peak when you see the bulb and then the mirror goes away the other side and that drops off. You couldn't do it with that one. So this only works if those rectangles are exact rectangles, because that's the only formula that width times height works for. Okay, So that's what it does. So we put in how many pulses we've got. And you see what the spreadsheet's able to do is, as you change this, it's able to say, it's able to put the right number of fields in and to show you the graph of what it thinks that you're telling it is the flash sequence. So if we put 4, we've put 80 milliseconds with no off time. So if I put 10 milliseconds off time, you see the graph changes. Now what's happening here is how we're doing this. How are we drawing a diagram in a spreadsheet that moves as we enter data? And that is the cunning part. What we're doing is somewhere hidden, i.e. here. This is all the workings out for this thing. But what we're doing is we're, I'm going to find the right bit. Yeah. This is the graph data. What we're saying is that there's formulas in here that look at how many pulses there are, what the timing is between them, and either put a 1 or a 0 in for on or off. So all that's happening on this sheet is that if we looked at the data series for that graph, it would point to this column and this column here. That's all it does. Quite simple, but it's very effective at giving you a diagram of exactly what it thinks it is. If we've got different pulse widths, and we can handle that as well, we can go 10 and 10. You notice as soon as I entered the second pulse, all the others went red to say, if they're not all the same, if you enter it in the first one, I'm going to assume they're all the same. If they're not all the same, you've got to put all the rest of them in. So we'll do 32 and 19, and then the last one. There we go. So that's the pulse chain we've told it we're doing. It's highly unlikely we would do one like that, but there you go. And then we tell it what the frequency is, 500 milliseconds in. Again, to help the user, it lets them choose whether they're going to enter hertz, flashes per minute, milliseconds or seconds, because people will measure things in different ways and understand things in different ways. And it will do the conversion here. Whatever you put in, it will tell you what it is there. It's worked out the total on time, which is what those added up are, and it's telling you you've failed. Because, did I tell you there was regulations for how long you could stay on for? There are. You can only stay on for 0.4 maximum of the frequency, and obviously we've gone above it there. So let's knock that down to 40. There we go, we pass all of a sudden, because we're at 0.38 frequency. Now, as an electronics designer, your aim is to get as close to that 0.4 as you can, because don't forget that the more gaps you've got here, the less light effectively you're putting out. So therefore, the little amount of peaks you are putting out need to be brighter, and brightness costs money. So it's a case of making it as close to that as you can possibly get. And then we've got a little table down here which looks a lot simpler than the other one. Did I mention you've got to let things warm up and you couldn't do a measurement straight away? It gets incredibly complicated, does all this. But basically what the regulations say is you've got to let the unit stabilise. Because obviously let's say some unscrupulous Japanese manufacturers, or Chinese manufacturers probably most of the point, would do one that works for half an hour and then packs in after that, and it's like, no, we're not going to fall for that one. So what they do is they do a measurement at 1 minute, and let's say they put in what the ILT tells them. There we go. And it's working out all the rest of it. And you can see, all of a sudden now, we've got columns with the same data as this. We've got JDT, which is that. In other words, that's what the integrated figure from the ILT is. We've got JM, which is what the peak that it's worked out from area divided by the time. We've got F, the form factor. Anybody know what form factor is?
ATX?
No. it's close. It's basically it's the ratio of on to off.
Oh.
That's what it is. So form factor. So again, 0.29. The closer we can get to 0.4 with that, the better. But that's where we are. And the JE, the calculated effective intensity of 197 candela, which is a pass. Great. The only thing it says down here now is waiting for sample to stabilise, and you can see there's a 15-minute one. So what they're saying is that doesn't matter. You've got to wait now 15 minutes and do another reading. So let's say the next reading gave 15. same figures, it's worked everything else out, but now it's saying weight. And that's because the regulations say that if the readings are more than 5% different, you can't carry on. You've got to weigh. That stabilisation means every 15 minutes you do a reading, and it's got to be within 5% of the previous. Did you see what happened there as well? This went a different colour. If I delete that, that goes back to blue. So every time you need to do another reading, it effectively puts the next row in to say you've got to fill that in as well. And what I try and do with spreadsheets, again, to make them more intuitive for the user is, if it's this sort of colour, it's a mandatory thing, you've got to enter it. If it's this, it's not. White is user entry, and other colours are usually light blue is a drop down, and I tend to do other colours for don't touch this, it's a formula, but I want the spreadsheet that says that anyway. So we've got that. So if we did another one, it was 15, now it says ready, pass, that section's done. So all your initial timing and everything is fine. We can so we can close that up. And we go on to, like we said, the photometric. So we've got here what the ILT tells us the reading is. So we'll use the same, roughly the same one, about 16, and lo and behold, it's a pass. Now, this was an info only test, if you remember. If it was a regulation test, there would be bars come up here with that colour saying you've got to fill those in. But this is info only. So we've done one test. We've told it it's likely to be a uniform product. So it's saying if you've done one and it's a pass, we're going to say the whole result is a pass. Okay. So that's where we are with that. We can put more in here. So if I put something in that would be, let's say, a fail, that's as well. There we go. So that's failed now, it's too low a value. And as soon as you get one fail, it's like, no matter how many passes you've got, if there's a fail, there's a fail. So that's where we're at with that. So we can fill these in. As I said at the beginning, it's now filled the angle in here. So this is amber, so it's -8, 0, and +8 would be doing the test set and putting data into those. And you can fill as much of these in. Obviously, there's a lot of measurements here, but you can fill as much of that in as you want. So what we're going to do with that then, we're going to graph it. We want to show the user what that looks like. Some easy way of saying yes, you've passed, and also something you might want to put on your data sheet or give your customer to say, here it is, it passes. So this is what's called a polar plot. And again, what we're doing here is we've only got one test result up here, and yet it's managing to come up with a whole circle of data. If you look at the key down here, the red is the class 2 data, and the pass limits, and we're passing in the middle here, it's 180. So we've got a whole circle of data from one figure. How have we done that? And the clue to it is this little bit down here, interpolate, yes. And what this is doing is saying, if I put that to no, because I've only got one figure, it's going to go up, and that's it. And that's not much use to anybody. If I've got another reading in here, let's say we've got 13, then you can now see that it would start to build up as it went round the circle at those various angles. But again, now if we go and say we want to interpolate, in other words, tell us what it would look like if we did them all round. And again, now you can see it's not using one, it's using more. And again, it's how are we doing that? Well, again, this graph isn't using this data. What it's doing, again, on our little hidden tab, there's a whole host of interpolated data here. And it makes an intelligent guess of if you've got that one in at 0 degrees, if that's your only if that's the only reading you've got, I'll use that on them all. But as soon as you put 15 degrees in, because it knows that these are circular things, it's like at 105, and 90 plus 15, and 195, and so on like that. So it makes an intelligent guess as to where these figures would be around the circle, and that's what's used for the graph. We can also display the min and the maximum. So I can display the class 2 limits only, and class 1 data only. And again, how is it doing that? Well, it's all back to this. These equations you can see here are looking at what you're choosing in terms of thing. You can see what it's doing. It's quite a long one, but it's basically saying whichever one you've chosen, I'll either blank that data to -2000 so you can't see it on the graph full stop, or I'll put it to what it actually needs to be. So that's the sort of thing we can do. We can say, look at the data the user's entered, or the option the user's chosen from a fixed list, so we know what it can only be one of a certain value, and then we'll play with the data to affect what's seen on the graph. And this is just the normal chart recorder type thing that you would see. So we got up, and these are your pass-fail limits. So we can do that, and these are also for the various angles then. This flows down -0 and plus angles down the screen. You can see here we've got the colour entry. So amber, how are we going to work out if amber? Now, I might have to change these because I can't always remember which is the right way around for a pass on amber. Yeah, there you go. So 0.59 and 0.4 puts you somewhere in the pass field for amber. Now this is one of the most complex equations I've ever had to come up with, because what they don't, it's hard to tell. I might have it here somewhere as to what the colour thing is. Is there another one still? Yes, there we are, CIE data. This is what they say in the regulation. They don't give you a nice simple, if it's this number it's a pass, and if it's this number it's a fail. It's not even as simple as if it's two numbers it's a pass, if it's two numbers it's a fail. Amber, what they say in the regulation is the limit to red is 0.39, the limit to white is 0.67, the limit to green is 0.12. That's what we'll tell you. It's like, what? What are you on about? If it's blue, the limit to green is -0.805, the limit to white is 0.4, the limit to purple is that.
Just on the Croce condition, really?
Yes. And the red, again, limit to yellow, limit to purple. Blue's the hardest one, because blue has more limitation. Red is quite easy, there's only two limits, and I'll show you why. So it's like, how are we going to work that one out? And also, you've got all of this. Now, this is nothing to do with what you see in the regulations. All you get in the regulations is these limits to, and these figures as to what they are. And you've got to, from that, work out, is it a pass or is it a fail? So, how do we go about doing that? The other graph I haven't shown you yet is this one. So this, as you can see, is the CIE graph that we showed you earlier. Now, Excel hasn't got a way of plotting this graph, so this is quite a unique way of doing this sort of thing. It's not a pie chart, it's not a bar chart, it's not a scatter graph, it's nothing that you would expect Excel to be able to do, but we can do it. And you can see here, that's the blue limit, that's the amber limit, and our little green dot is in there, and the red limit you can just see down there. And we've split those three graphs out, so you can see that's the shape of the blue, that's the shape of the amber, and where we sit within it, and that's the shape of the red at the edge. So, how have we done it? What we've done is we've used the CIE equation to come up with a boundary. This boundary graph here, this line here, this boundary is created by a series of points that are defined by this equation. This is the colour equation, and what it's doing is for each wavelength frequency, and these are plotted in 1 degree wavelength or 1 unit, put the frequency into this, and this is what you get. So this forms the edge of this graph, and if you would tell Excel to take that and use basically plot an XY where it links all the points together, that's the shape it gives you. So that's the shape that those series of points give you if you plotted it. So where did the colour come from? Well, that's quite easy. That just Excel lets you overlay a graphic. So what I've done is I've pinched the graphic off the web, sized it and skewed it, because you can turn it round, you can squash it one way or another. You can see it doesn't quite fit at the top, but it doesn't matter. It's not being used as anything accurate because it tells you it's passed or failed using different methods. It's just to say roughly where it is in the colour chart. And that's why these don't have the overlay graphic, because you want to see exactly a bit clearer. So that's how we've done the graph. How have we worked out whether it's a pass or a fail? So let's look at this sheet a little bit more detail. What we want to be able to do, like I say, is these sorts of things need a lot of error checking, a lot of attention to go in to not tell the user something's passed when it hasn't, but also not to tell them it's failed when it hasn't. So you've got to make sure you're doing it. So what all of this is all the stuff you see in those drop-down menus: type of light source, colour, the angles, the seconds, how they're going to measure the frequency. In other words, this is all what the user can choose from that's represented on that front page, and this is where Excel gets it from. It's all on another tab, so the user can't see it and mess with it. But that's where I keep it. The other thing it has is various data. So with these sorts of tests, there's several different ways you can look at these tests. And you could say, I'm doing a full certification test, and it would force you to do every reading. So that's about, I think it was 18 around there, we decided every 15 degrees. So, and until, which is fine, but it would take you all day. But if you're going to spend £3,000 sending it off to have it tested, you don't mind spending a day to see whether it passes or not. So you can see, this is the validation rule for a beacon, a lead beacon at 0 degrees. Yes, we're going to do a test. We're going to force the spreadsheet to say it's an essential number. And you can see, for a certification test, every number is essential. Everyone's got a 1 in it, so you've got to do them all. And then we've got this word here, COP. And it's not COP, but it is COP. And that's called conformity production. As I explained, with colour, with this sort of product, you've got to test these in your factory every so often. You've got to assure the servicer, the regulation body, that you can produce these the same all the time. And the only way you can do that is to put a dark room in your factory, buy this gear, and do these tests. So what we've said here, for COP, we only really, on beacons, we only really need to measure half of it, because the other half's going to be the same. And so on. So some are ones, some are noughts, depending on what it is. And for an information-only test, this might be you just testing somebody else's equipment. You want to see how theirs performs. It's like you're not bothered. You don't want it to say you've got to do 3,000 measurements. However many you want to do is fine. So they're all zeros. So that's how that works. And then again, we've got some more menu items for the different classes. We've got the data for the graphs that we showed you. And then we've got this. And this is where a lot of the error checking is done. A lot of the calculations are done. So in other words, all the data that you see thrown back at you on those front screens here, if we go back up here and look at some of this, where you were entering timing stuff, it was saying down here, all of this is 2 Hertz, the utilisation factor is 72%, you're at 0.38F, all of that comes from here. And this is where all the calculation is done, where you can't see it, you can't mess with it. But all of these, or even just constants are stored here, the constants for feet squared to metres, distance to the dark room is that, and so on like that. So you can see some of these equations get quite large up the top there. Some are just dead easy, some are just text. But when we get down to has it passed colour or not, let's have a little look. Find it. Here we are. Blue colour calculation. Here we are. Now, when I started doing spreadsheets, anybody try to do an if statement on a spreadsheet? You'll know that you can only do one. And if you want to do more than one if, you have to nest them all. So you have if, and then open bracket if again, and open bracket if again, and it's like, and then you end up with about 15 close brackets at the end, and you can't work out which one's which and where your other one needs to go. This is a brilliant way of bypassing a lot of that. And it's the good old and or. Because if you think about it, what you're, with multiple ifs, you're usually saying if x equals 1, do this. Well, that do this is often also if y equals 2. Well, you can just do that with and x equals 1, y equals 2, close bracket, done with. So that's what this is doing. It's testing that colour. These are the limits we saw above, using a lot of and or to come up with basically it's doing geometry to say are you within that thing or not, and so on. True is another good one. I was going to do a little quiz about true. Rick might know this, but again he might not. What's false and true on a computer?
Numerical things.
Yeah.
I seem to remember it's true minus 1 and
yeah.
0.
It is in basic. True is always accepted to be 1, generally, and false obviously is not. The problem with true is it depends what you're reading it in. So to spreadsheets, true would be 1, which is sort of what you want. That's what you expect. But if you're writing computer code and you put equals true, you need to be certain you're dealing with what you want, and Rick's perfectly correct. If you put print true on BBC Basic, you get -1. Can anybody tell me why?
Because it doesn't naturally occur.
No?
I always used to take anything other than 0 as being true.
That's the thing, not 0, but that depends. That can lead you to problems. So if you accept that false is 0, anything, it depends how you say not. If you do a not equal to 0, then you're fine. But if you put the keyword not 0, you'll get -1 again. Why do you get -1? Go on, a mince pie next week for anybody who can tell. No? Right. So, how are numbers represented in computers? A bit is simply a 0 or a 1. That's fine. A byte is 8 bits, generally. Okay. What happens when you've got a word? What's bit 31 in a word, Rick? Usually. It's a sign bit. It's a sign bit. So, according to a computer, when you say true, it sets all the bits in whatever variable you're telling it to make true to 1. But most number systems that deal with large numbers, like C or like BASIC, they use the top bit as the sign bit. That's how you can have plus and minus numbers. So it even sets the sign bit. So all the bits go to 1, which to most systems is -1. So that's why true on BASIC, and if you did it in C, if it was a signed number in C, it would come out as, well, C as constant, doesn't work the same way, but certainly with BASIC, that's why true, you put print true, you get -1. And that's why it's incredibly difficult if you're writing certainly BASIC code, and you put if so-and-so equals true, you expect your variable, you're wanting to check for 1, you're actually checking 1 is 1 minus 1, because it never works. So that's why you've got to be careful with true and false on computers. Normally these programs will have these constants predefined, but like I say, BASIC has the keyword. But it's ridiculous, really. It equates to -1.
There's something slightly more confusing as well. Because if you're writing, let's say, shell scripts or exit codes, then 1 is false and 0 is true. Although not supposed to be used like that, but zero is a 0 exit code means success.
Yes, success. But you shouldn't do like you see. Again, those compound C as a constant defined as exit success. So when you return from a routine, you're not meant to just put return in brackets 0. You're meant to put return in brackets exit underline success to say it's a successful outcome. So that's just lazy programming.
I was thinking shell scripting more than
yeah, but you're right. Usually
just
exit from a
confusing
routine as 0 to show that it's okay. Yeah, because you'd be exiting with an error code usually, something like that. Yeah. Okay, so like I said, a lot of the calculations is done off screen sort of here, and this is just how I want to lay it out. And you can see, just for my purpose, I put the units and so like it was a long spreadsheet name and put it in there. It needs the equations with the this one, try and abbreviate it. So that's that. And another important point with this one is, I know the next customer for this is in Spain. Well, clearly, if he's got a Spanish-speaking only technician, you don't want to go through all of this and change all of the things. So another useful feature, and actually the Acorn ones that I've seen do let you do this, but I've not played around with how good they let you do it, is you can create named areas or just names that represent a particular cell. So what we can do is, if we go and look at some of the equations, not on that one, but on this one, it's printed a whole load of text, but if you look up here, that text doesn't appear anywhere. And that's the reason being, this JNMD is a reference, is a name that references something. Now, we're doing a comparison there, so JMMV must be a value ultimately that it's comparing, it's not just some text. But it's just a way of me, rather than having to remember cell numbers, because as these spreadsheets develop, rows and columns get inserted and deleted and so on, but if you name a cell, it retains that name wherever you move it to, so you don't have to worry about the reference changing. So I'm thinking JM is maximum minimum voltage or something like that for the JM. But this is the interesting one, this VPKM. So if I go here and just put equals VPKM, we get some text, and we get a particular piece of text. What that allows us to do, it's almost like when you're writing programs and you put all your textual resource in a file that somebody could, if they wanted to, change to a different language. And what we can do here then is a tab called text, and this is all the text that appears in the program. So this is its tab name, or its name. I just put it there to remind me. It's not a lookup that Excel uses. You program that somewhere else. But this is the English text, and you can see at the top here, or rather, this is the text it's going to use. This is the English one, and because we've told it English, they're the same. If I went up here and chose Spanish, come on. Okay. I made it so if there was nothing in the language you chose, it used the English anyway. So as soon as I put something in here, that will turn to be something. So they weren't left with nothing if they hadn't filled the translation in. It's just, if there's nothing there, it'll use English. If there is something there, it'll use that instead. So you can program this with up to 8 different languages. But like I said, I know the next customer is Spanish, so he's going to have to go in and put all that in. But what it will do then is it will use that text in all of this. Every piece of writing in all of these sheets comes from that language table. So it's quite easy for somebody then to go in and just fix the language. And the last thing we wanted to do with it is regulations change over time. If you've got something hard-coded into your spreadsheet, it's like anybody who's run an accounts program, every year the tax rules change and you need an update for it. It's the same with this. These regulations change almost yearly. So you want a way of updating the data without having to go and look in every single cell. Where did I put that maximum? Where did I put this? Where did I put the past level? So what I did is I put it nicely in the exact format it appears in the regulation. They give you tables like this to say these are the pass fail limits for blue, amber, red, the maximums, the minimums, the directional lights, the maximum percentages, and so on. So this is what is used to calculate in the rest of the spreadsheet all those, as it passed or hasn't it passed. But again, the user would be able to go in and alter this. If the regulation changed, you could just come in here and say, I'm going to change that because that's what it says in the book. So unless they do some fundamental structural change into how you test, that's all they will need to do. So
why do they keep changing these limits then? Is this just to keep somebody in a job?
Partly, yes. I mean, like I say, when I was in emergency lighting, most industries are governed by regulations, and certainly in that one year it came out where it used to be the case where you were allowed 20% voltage drop from the battery to the luminaire. Fine, okay. Next version of the regulations came out, it was 10%. Well, it didn't take much to work out. Let's just see who sits on the committee. Oh, Pirelli cables. You suddenly needed a lot thicker cable, so you'd only dropped half the voltage. So these things are driven by that sort of thing. And
yeah, I had my suspicions.
I mean, there was one where, and I used to get to see the minutes of all these committees and meetings. There was one where they wanted to, and I've noticed them doing it now, so they obviously got it through. Most lights on cars now are becoming LED, whether it's headlights, indicators, so on. Headlights are always the problem, simply because, as I said, the amount of light. Everybody thinks LEDs are efficient forms of light, and they are up to a point. They are up to a point of, if you don't want much light, fine, it doesn't take much power. But I know of LEDs that take a lot more power than a bulb, and the problem you've got is cooling the damn thing. The bulb is quite happy to get so hot you can't touch it.
Yeah.
An LED, you get it that hot and it might last 10 minutes.
I've got LED floodlights now outside just to avoid having to climb up ladders to change bulbs.
Yes.
Massive insects on.
Exactly. Well, there used to be a really good graph, and it went like that. And this was power, watts. Anybody want to guess what this was?
Volts? No, of course it can't be. Light?
So in other words, the more power, well actually this wasn't watts, it was temperature. So it's all down to how hot you get it. But this was the junction temperature of the lead, and the hotter you ran it, actually that's the, is that the other way? Yeah, that's the other way. The hotter you ran it, the lower it got. So these, when you go into a manufacturer's catalogue, and it used to be quite cynical, they would say, this LED is good for 100,000 hours. So you get your calculator at 24 hours, we're going to run it 30% of the time of the 10 years life. So you start seeing manufacturers saying 5 years life, 10 years life on stuff. But that was at 20 degrees. You can't run an LED at 20 degrees. So you turn it on, it goes up to about 40 or 50. So it was rubbish. So actually now they've all agreed to publish the life figures at 80 degrees, which is a reasonable thing. But even though, you know, it would, every 10 degrees, life would halve. So your 10 years LED at 20 went to 5 years at 30, 2.5 years at 50. You see where this is going. You're down to 6 months on some of these. If you drive them, and a lot of these products drive LEDs at about 100 plus degrees at the junction temperature, and that's why they need a massive heat sink. Yeah. But it's the most efficient. LEDs are really expensive still, but you know, they can take as much power. You know, you can get 10 watt LEDs now. Well, something like this, you can't power 360 degrees with an LED because they're very much directional lights. So you'd need a tower with several of them around. So you know, with 10 watt LEDs, you're starting to get up to 40, 50 watts. Well, an incandescent beacon bulb is a 55 watt one. You know, it's. So anyway, so again, that's a nice way to give the user some control of what is entering on all of this. So that's an example of quite a complex, yes, and it took me probably about 4 weeks to do that, and I sort of knew what I was doing because I've done that before. I've done the equations before, and we've done a similar thing before. We've got a button down here for clear user data. So the worst thing with something like this in the tech, I used to get a call from the technician of this company, this LAP company in the Midlands, and he'd say it's giving the wrong results. Can you come down? Well, I can if you pay me, which they did. And come down, I'd put it in the dark room, and I'd put in the results exactly, and it'd be fine. I'd say, it's exactly what it says on the certificate you got. All right, what did you put in? Well, I put in 10 milliseconds, not, and I says, well, let's go, it's 12. Well, it's near enough. I says, no, it's 20% out. You know, little, on these things where the number isn't big to start with, the margin of error that they were coming up with was huge. And we used to measure the light for 60 seconds, and we had it, all right, we had it with a clock. But how hard can it be? If you're a second out, all right, it's what, 1/60% error. But you know, these things can add up, and it's this lack of thing. And the worst thing was, I'd say, well, have you got that figure? Well, I loaded a previous version, just tweaked it. And it's like, yeah, you haven't deleted some of the old data, so he's running it with timings for a beacon that he tested last week. So we put a clear user data button in that you press that and it wipes the whole lot. And you wouldn't believe it. I mean, you think they'd be more clever, and they are clever, but a lot of these people are under pressure. They've got a lot to do, and you know, they want something that you can run it, put it in, do a 5-minute test, and it's like, you can't do a 5-minute test because this at least says we've got to wait 15 minutes, and that's before you start any of this. You know, so these regulations they're not always that simple to comply with. So that was that. Have we got anything else? We were going to talk about the ACOL ones.
You know, as a customer, you bought a product like this, and it is for a warning light, it's not just... Is there anything on that you can refer back to a database to see that it has been tested properly?
The database, yes, the database screen had the when the next test is due and what the result of the previous one was over here. It would tell you where when the next one was. So this part of it, they would put in when they'd done the test, what the result was, what their retest period was, and it would come up and tell them when the next test is due. So they could look at this. That was the whole idea. They'd keep this up to date as a database of all their certificates, and it would tell them when to do, when the next one was needed doing and needed doing.
Because you can say, well, there's a manufacturer, you know, well-known manufacturers producing these, they're doing all the tests, having them certified and so on. There's obviously lots of stuff coming out of China and stuff.
Yeah.
It's churning it out.
Yeah.
How do you know that it's been
Well,
tested?
this is always the problem with things like this, is that Europe and, if you like, good, conscientious countries and economies will put these regulations in. But the problem is not everybody abides by them, and it's not so much the fact that the regulation isn't there. You know, if people follow the regulation, everybody's lights pass, then everybody's happy. The problem is in the policing of it. And it was a long time, they are now getting to grips with it, but it was a long time where you'd see things on the back of a van as I'm driving up the motor, and I'd say, there's no way that's passed. There's no way that's passed. Now, in terms of, and this applies to whatever regulation, CE marking, whether it's a Charles 90, a teddy bear, or this is purely CE mark because it's an industrial beacon, so this didn't actually need to be done like that. But the responsibility is with the person who brings it over the EU border. So there's no point trying to go and prosecute a factory in China, because the chances are it's not there. They'll deny it was ever theirs because their name isn't on it. You know, so the EU has said we will prosecute the person that brings it over the EU boundary, and they are the people who are responsible for checking that it does meet the regulations. And that might be, do you trust the manufacturer? If not, you've got to go and have it tested yourself. And the regulation actually say this. There's the WE and the ROSH regulations, which are the waste electrical stuff, in other words, thou shalt not pollute the earth, and the ROSH ones, thou shalt, you know, WE, you shouldn't throw it away, and the other one is you shouldn't have anything nasty in it. They are very much, I got the regulations, and without a shadow of a lie, they are two-page of requirements, 17 pages of how we're going to prosecute you and what the penalty will be. Because there isn't enough people doing the checking and doing the policing to make it, they're going to get anywhere close to fixing this stuff. All they're going to do is they're going to say it's done by exception. If something happens and you're caught and you're found not to have done the proper checks, sorry, but you're going to prison. And that's what happens. And the regulations became quite succinct in basically, they had a certain set of words. First off, there's a term called strict liability now, which is you have no defence. You did it, it happened, you have no defence. It's the same with environmental law. If oil ends up down the drain, doesn't matter what excuse you came up with, oil went down the drain, therefore you're guilty. So there's a strict liability clause which stops you, and it says there is no defence. No good, there is no defence. And the other line was, anybody in the organisation who knew and could have or should have done something about it is guilty. So you can't just blame the MD. I was the engineering director, I would have gone to prison. It might be my engineering manager, if he knew, he would have gone to prison as well. So it's the selling this fear factor all the time of you'll police it yourself, because if you get caught, the penalties are pretty severe. So that's how it's happening, unfortunately. So
so you couldn't have, for instance, have a certificate number on the product that you could go on a computer and check a central database to see?
No, they don't do that. They did think about doing it at one point for this regulation, but they didn't want competitors checking upon other people's equipment. You know, that's just the way it is. Sorry, Rick, you were going to say something.
No, just coming back to the LED floodlights, sort of similar. A lot of them, well, certainly through eBay, but even through Amazon, have come from Hong Kong. I've had several and immediately raised a complaint, and not earthed.
Yes.
CE marking on them,
Yeah.
metal box, metal casing, and inside there's an earth lead,
Yeah.
and there's a ring tag on the end.
Yeah.
And it's just floating loose because there's nowhere to fasten it to. And it might just be resting
Well,
against the inside of the case. So if you
Yeah.
do a little continuity test,
Yeah.
it seems fine. You take the back off.
There's
And then you start to read the reviews. Major problem, and they're all CE marked, so it's got to be fake.
Yes, exactly. Well, we used to import. I didn't like buying stuff from China. And in fact, I didn't like it at all, because the purchasing girls would say, you know, we're buying that, but company X has come with this one and it's half the price. Can you prove it? And first thing I say is, I want to see the certificate. Right, what certificate? I want to see the R10, the MC certificate, because they all have to have one. Okay, they come back saying, can you send an example? And you can have it tomorrow. Now, I know it's a 6-week lead time to have it tested and approved, and yet they were more than willing to just mock one up and send it back. And it's like, no, don't, just don't. Don't even go near them. But no, that particular example, Rick, I mean, there's 2 regulations of breaking now: low voltage directive, because it's mains, and also the general product safety, thou shalt not kill. And that's what they're doing, you know.
I mean,
I used to do a list with that. There's thou shalt not electrocute, which is EMC, LVD. Thou shalt not interfere, which is R10. Thou shalt not kill, which is general product safety. Thou shalt not blind, which was the RC. And all sorts of and there were about 10 regulations. I used to call them the 10 commandments. Of, you know, thou shalt not leak, the IP one. So it was quite interesting. So
things like that I buy from UK supply.
if possible,
Because
I mean,
they are, as
yes.
you say, they are so scared of being
Well, look at the
prosecuted that the goods are genuine.
I mean, look at the things with the Halloween costumes. I know it's not relevant to electrical stuff, but they've all got CE marks on.
Yeah.
But you see a lot of CE marks that are fake CE marks because they don't really know what it is. And in fact, I think I probably said this before, China brought out a regulation that mandated a CE mark, and it stood for Chinese equipment. And that's what they did, so that they could say it's CE mark. Yeah, but it's not the same CE mark, not the CE mark.
Well, you're thinking, is it Serena McCollum? Someone like that?
It was the woman who does Strictly, wasn't it? It was her daughter.
I can't remember her name.
Yeah.
Terrible, really, but
Yeah,
you know that's what they do. The company I worked for did the flashing lights, but they're part of a larger group. And the American had a company called Amber. Well, one of the products was called Ambersil, and it was the American version of WD-40 that they
I
made.
know, yeah.
And they went to source it. The purchasing guy says, "We can get this out in China. We've been offered it." He went out there, looked at the factory. Oh, okay, right, we'll have some. Put it on the shelves in America, and the odd can started to explode, and eventually it burnt a warehouse down. So the MD says, "Get on and go over there," and went over. Very sorry, we'll do it with improved version. Burnt another one down about 6 months later. So the MD says, "I'm coming with you." Got on a plane, went to this factory. It was an empty shell. And this is the problem with China. They said to the locals, "Where have they gone?" "Oh, the factory that was there." "What factory?" "Nobody there, ever." And they've never found them. They've never found. And this was a 50,000 square foot factory full of machinery, and they just up. Whenever there's a problem, they just up and move, and you just can't trace them. Unbelievable corruption, absolutely unbelievable.
Yeah.
Right, Acon spreadsheets.
Remember Anderson?
So I'm going to have to run this using the RPC EMU, which is a little bit slow. It says, just have a nasty thought. They're on my server at home and not on here. Let's have a look. Oh God, I don't believe I've done that. Okay, let's see if they're on virtual icon, but I'll see. Right, there's a chance there might be. I think piping will work. I think results probably once a file I haven't got, but we should be able to run. Like I said, I did want to show that and the closest I could get to it on the Acon, and I have to say, it didn't take me long before I gave up. That's the one that doesn't work. No, neither of them works. We might not get very far, yeah? This is one of the sad things now with Riscos I was going to comment on as well. I downloaded the free version of Fireworks and Pipe Dream, and obviously I'm running Virtual Acon, and neither of them wanted to run. They said I haven't got a shared C library that's suitable. But it's on the machine, but they won't load it. So, modules thing, see if I can find it. Where would modules be? Anybody know? Is that? Oh. That's it, 6585. I think one of them will crash then, but Hydrig's okay. You know, why not load it? And what I found then is if I load it and run other software, some of the other software don't like it crashing. It's pure, I think it's just down to the, I don't know, it's down to the fork in the operating system or whatever, but when you're a minority platform anyway, it's the last thing you want. Okay, so like I said, I wanted to try and get as close as I could on these to what I've done on Excel. And I know Excel is an expensive program and it's got a multitude of developers, but as I say, I fell at the first hurdle because what I wanted to do, the two major things that does is uses menus as a way of limiting the user input, and it uses VLOOKUP as a way of looking up from tables what figures it should use. So let's try and do a list. So we've got yes. That's the other annoying thing, you press return. Oh, you've done it there, the swipe. It didn't move. Excuse my typing. Right, yes and no. So can I make those into a list? No, I can't. There's no facility to have those two appear in another cell as the validation option. So, okay, you'd have to rely on them putting yes, but then what happens if they put
Maybe.
yes, lowercase? What happens if they put yes, uppercase? Now, there's probably formulas to convert text or do comparison case free, but what you'd have to convert what you're checking to lowercase as well. And then if they put something other than yes or no, you've got to put an error box up or put a message next to it saying, so your spreadsheet suddenly becomes a, if this is not yes, put, you idiot, you should have put yes. It just becomes incredibly difficult. Let's have another go with VLOOKUP, which is another popular one I use. So, the way VLOOKUP works is you've got a list of names, for example. So let's go Mark, David, John. Right. And what you want to do is look up from that based on another value. So I can't put, see, this is the annoying thing. I'm clicking on F and nothing, it's not doing it because it only lets you enter where you've already put data. Unless you use tab. It's just infuriating. So I'm just going to put a simple. See, it didn't move. Look, it don't move. And, it moves, but look, it didn't move then. It moves when it wants, which is again just be consistent. I'm already pulling my hair out, and I've not even tried the VLOOKUP formula yet. Now, in Excel, if you want an equation, you put an equals in front of it. That's how it dictates it. No, you don't. You have to go and type it in here now. So, all right. So we'll do VLOOKUP. So, no nice help text. Okay, well, we'll give it a go. You look up against the value. So let's say we're going to make A4 a number, and we want it to tell us the name. I know it doesn't have a number in the moment, but it's A4. And then we need to tell it the range, which is there to there. Fine. And then we tell it which column is the number, is the data we want, because you might have several columns. It needs to know which column it's going to do. So this is going to be column 2, I would imagine, if it starts at 0. Okay, let's change that to 1. So what I wanted there, I'm going to put an equals in front just to make sure that it knows this is an equation. Yes, it does, and it's not done it. What I wanted it to do there, put a 1 there just in case it starts from 0. Oh, it does. Great. So you see what's happening. We've put 1, and it's looking up where 1 is, and then it returns the value in column +1 mark. Let's see what happens if we put 2. It hasn't changed. It hasn't put David. And it's just like, what? So you begin to question your sanity. Have I done something wrong? No. The reason it hasn't put David is because it expects that list to be in ascending order. Well, I'm sorry, but the spreadsheet might not dictate that I can put that list in ascending order. I might not be able to resort it. It might just be that's the way it is. So again, it's poor in terms of its user interface. Like I say, I can't go and put. It's doing stuff now. Look, I can't get to H2. It's always just going to the back of that. It's I know why, because it thinks it's behaving like a word processor. It's just putting the caret on the end of the line, which is the end of the word job. It's not behaving like a spreadsheet, although I chose spreadsheet off the menu of the template, and this is just programs like this. There are plenty of word processors even on the Acorn market. We don't need this to behave like a word processor. We need it to behave like a spreadsheet, because as I showed with Excel, you can do a lot with spreadsheets with just text in cells. You can make it look okay, but you don't need to use it as a word processor. This should be a spreadsheet foremost. It might have some nice word processor type tendencies, but it seems to me they've done it the other way around. And of course, because Fireworks is the same sort of thing, it's the same group of programs, just a bit enhanced, that works exactly the same way. It's just a complete now. I never got even further than that, because it's like, well, without those two features, all you're doing is a flat spreadsheet. As I explained at the beginning, you can put some numbers in, you can probably graph it, and you can put it in your desktop publisher. It's never going to come up with the sort of spreadsheet that we've just had a look at on Excel. The other thing we can do, I know, like I say, it's a totally different platform and so on, but this is really where Acorn software ought to aspire, especially with the Raspberry Pi coming out, because the Raspberry Pi is a great little industrial computer in a way. And what Excel will let you do, it will let you capture data from serial ports and fill in cells on the spreadsheet and so on like that. And that, to me, is what these things need to be looking at now. At the moment, Windows doesn't run on the Raspberry Pi. But if these things could start taking that data in and doing things with it and have a bit of programmability and be able to control stuff, it would be a really, really good, thing. So I failed miserably on both of those. It was just, it's not even good enough that I would want to use it. I'll just flip out to Excel.
Because I'm really bad with Excel. But one of the things I like, one of the I won't say I like, that's I use Excel for is filters, and I've not even found a way of doing filters.
No.
I mean, even if you're just using it like I did for massive columns of data, which you might have like 2,000 cells plus, you can't work with that.
No.
So, and if there's no filter, it basically means the spreadsheet is almost unusable.
Yeah. I'll show you another one I did. I think what it might be under. There we are. We wanted because again this shows the power of lookup thing, the VLOOKUP. We wanted a program to cost things up for us, let the sales reps or staff in the office be able to cost up quite complex options on light bars. How long is it, what are the lens colours, all of that, and do a price without us having to do the engineering work to tell them what the price was off the bill of material. So we did this one, and again they could choose an RRP price or a net model price. They could choose which model range they were doing, and they could choose their currency. You see what's happening on the right hand side here is this data is changing depending on what you put in. So we're looking at the chassis. These things are built up obviously by bolting various things together. So we start with the chassis. So let's say we're going to do a 1200mm light bar, and we put quantity 1. We then go and say we're not bothered about chassis now, we want to look at the lenses, and the list changes, and this list is coming from this list. So you haven't got a massive list of all the components you could possibly choose from. It's limiting, it's doing a VLOOKUP here, and then it's using this as the validation list for its menu. So it's quite good in that it limits them. They can't then choose the wrong thing. They can't choose a 60 series base and a 15 series lens and so on like that. So it's quite good like that. And I have a feeling if I choose the same thing twice, it might. I don't know whether it's clever enough to tell me. No, I don't think it is actually. It would, if I put too many light sources in, it says to, there's some logic built in there, but this is quite a basic spreadsheet in terms of it's not doing much. It's a few coloured cells. It's a sum price. Give me the total price job. But none of the Acorn stuff can do it because it can't do the list and it can't do the VLOOKUP properly and it can't do the validating input. So it's a shame because these aren't sorted alphabetically. I can't. I just want to add them onto the end. Sorry, that's just the way it is. In terms of filters, what Malcolm was talking about. Let's see if we can. Oh, we should be able to do some filter on here actually. So this is the dump that we would get from the MRP system every year of the updated prices of all the parts. And what we could do is we could go to here and say filter. So we've got now little drop-down menus on the top of here, and we can do cost. We can do smallest to largest, and it sorts them by price. It's not actually changed very much, but it makes subtle changes. It can hide cells. So, for example, we can go and say we don't want to see anything above £25. So we could untick all these boxes. You see, these are all the various different options. Now, because all these prices are different, there's a tick box per one. But if these were just common answers like yes, no, yes, no, yes, no, you could just hide all the no's. See the yeses or vice versa. You see there, it's shifted some up. But it's done it, look, just by hiding the row. It's going to jump from row 10 to row 19. So the data hasn't gone, it hasn't sorted it, hasn't changed the order of it. All it's doing is it's filtering what you see. And that is a very, very powerful tool for just getting the data in a way that it makes it. Because don't forget, spreadsheets are all about analysing the data. That's really what they're for. And that's something that, unfortunately, the Acorn stuff is sadly lacking. And there's other ones for, again, largely based around regulations, but again, there's a lot of logic goes into some of these. Some of them don't look very, very large. And just lastly, there was one I did for my wife's company. I ended up doing a lot for my wife's company, but this one calculated redundancy pay because again, it's a statutory instrument, so you can put in for one user all the details of what the pay is, length of service, age at termination date, because all these have an impact on how much redundancy you would get.
So you were the first to be made redundant?
Yeah. Annual salary, notice period, and it would calculate it all. The good thing with this is, again, she could dump a whole load of data in. So if her manager says, can you do me a price for making this whole department redundant, we've lost that contract, she could dump in the whole department data into there, and it would give her a group figure for it. But again, where it comes from this, and this is laid out like this for an exact reason, that this is what appears in the government's paper on it, exactly like that. So if these number of weeks per age per year of service changes, she can just copy the government's data, put it in there, and the rest of the system works fine. So it's very it's very useful to be able to do that sort of thing, but it's just unfortunate I couldn't do it on the Acorn. Any questions? No? Okay.
Rock, helping you with Acorn and RISCOS computing.